Solving using division. In the last problems, they were presented to us with division to begin with, like y over 2 equals 4, and we had to double both sides. Instead, we now have problems where it might look like 13x, and then we're going to have to divide. So let's take a look at this. Well, I should probably be able to talk about these a little quicker than the last set of problems. So this one says 13x equals 195. I see multiplication, so I'm going to have to undo that by dividing both sides by 13. Since this is a worksheet type setup, I know they are notes, but it's just right there for me. I can take my original problem that's in typed up print and divide both sides by 13, just showing it as a fraction. Do not show divided by 13 like that. It really messes you up for later, and it's a habit to break today. Okay, 13 is a prime number, so there's really no canceling out here. So just type that in, and it's 15. All right, then we got to check it. 13 times 15 is hopefully equal to 195. And when I evaluate that in my calculator, I do get 195 equals 195, and I check it. Let's move on to problem 2. Let's get zoomed in here. Negative 3x equals 12. Well, the opposite of multiplication is division, so I'm going to show a fraction bar, and it's not enough to divide it by 3, because if I divided it only by 3, I would have negative x. So I can't just divide it by 3. I have to divide by negative 3, and anything I do to one side gets done to the other. Slash this out so that we see those going away, and we will be left with x is negative 4, because 12 over 3 becomes 4. When I go to plug this in, I have negative 3 times x, but x we just figured out is hopefully negative 4, and that should be equal to 12. I can rewrite the right side if I want, because it's just coming down in each step. There's nothing simplifying or being evaluated. And then on the left side, 3 times 4 is 12, and a negative times a negative gives me a positive. We don't box this, by the way. If you are in the habit of boxing this, don't. This is our check. We box the solution, but not our check. Number 3. 84 is equal to 3b. And then in number 4, 8m is equal to 0. Make both of these OYO. I'm going to put the answers up and talk quickly about them in just a few seconds. So pause this if you have not already. There's the work for that. First, divide both sides by 3. Figure out what that is in a calculator or your head if you want. Evaluate the right side by plugging in the answer. And you're done with that one. I'm going to slide over and put the answer to the next one up. And you should already have worked on this. So pause if you need to again. Common mistakes in here is just if you're tripped up by 0. The other thing, too, is you probably just quickly said to yourself, well, anything times a number that would end up being 0 has to be 0. But that's okay there. Now, I want to point something out. This is going to be a misconception. In these one-step problems, a common misconception is just that you rewrite junk and you're not actually checking it. So let me show you something when you're going to check a two-step problem later on. So this would be a two-step problem, and let's say that you solved this and you figured out that x was 2. That means that I would have to plug 2 into the original equation, so it would be 2 times 2 plus 1 is 5. Now, a misconception that gets created is you just always rewrite 5 equals 5 or something. But what that doesn't show is this in-between step here. Now that I've shown the in-between step, it helps me see that we're actually evaluating the left side and bringing it down to verify that the left side, once we plug in our solution, is equivalent to the sides on the right. And I point that out because it's a common misconception in these. They're always just one step to check, one step to check, one step to check. And as we do that again and again and again, some people create the habit of thinking, oh, it's just going to be this equal to that. So I don't want you thinking that, and let's make sure we head that off at the pass. I'm not sure what I'm trying to say, but I think that's a saying that you'll be clear on. Google it if you're not. It's old stuff. All right, 3 is equal to negative 1.5x. Now, the thing that happens is people panic when they see something that is a decimal. So in red, I'm going to cover this up. Now, whatever this is here just needs to be undone. And since that's multiplication, we just always divide by whatever that is. So even though it looks peculiar to some of us, we're going to divide by negative 1.5. Sometimes when that happens, somebody wants to divide by 3. Well, the 3 is not attached to the variable at all. So we're dividing the left and right sides by negative 1.5, which means that I can just take my k and move it to the left side because it's going to be on its own. So here's k is equal to, and I would probably suggest getting a calculator out, because as you try to do this in your head, unless you're really confident with this, it might throw you off a bit. So now you get k is 2, which ends up being a whole number. Now, since they did give you decimals, if you ended up with a decimal answer to a decimal problem, that can be okay. Okay, now like in the previous parts of these notes, I want to show you what happens when you have one to write down on your own. So these are multiplication problems that we are solving through division. So if I had negative 2x equals negative 100, that is our original problem. And like I said, when we go to our steps here, we can, because we're using the same writing utensil, forget what the original problem was. And as we cancel things out and find that x is equal to 50, we get further from the original problem, and I'm just showing you this, that as you write these in your book, keep an eye out for that and know what you're doing in what process. If that's unclear what I'm saying, then feel free to hit me up for a better explanation in person. And then when I plug this in, negative 100 equals negative 100. Had I got something like negative 100 equals 200, we would know that we would have to revisit our work and double check what we did, because those two do not equal each other. Okay, now these are those extra types of problems, and we'll see how those go.